Hello students, welcome to Machine Design 1. We are in second module. We have solved several problems. Few problems using instantaneous center method and two problems we have solved using relative velocity method. We are going to solve third problem from relative velocity method. Here they have given crank and slatted lever quick return mechanism. Crank and slatted lever quick return mechanism. Okay, crank and slatted quick return mechanism they are given. They are given the dimensions for the crank and slatted quick return mechanism. We have to find out the velocity of this ram. We have to find out velocity of this ram. Let us see the dimensions of the mechanisms. So they are given a crank. They are given a crank. Crank is OA. Crank is OA and OA length is 60 mm. Crank is OA. OA length is 60 mm. Then NOA. NOA means uh, speed of the crank OA. Okay. Actually, it should be a subscript, but here in PPT, I think the option is not available. Speed of the crank OA. Speed of the crank OA is 200 mm RPM and it is rotating in the clockwise direction. It is rotating in the clockwise direction. Then CD, this slotted bar. CD length is 300 mm. Then this connecting rod DR. DR length is 400 mm. Then the angle between BOC is 120 degree. The angle between BOC is 120 degree. Okay, that is this angle. Wait, I will highlight the angle. This angle is 120 degree. This angle is 120 degree. Then OC, this fixed link length is 160 mm. Then what is they given? Distance between horizontal line from R and point O is 120 mm. This distance, if you draw horizontal line, and here also horizontal line, it means here, this distance is 120 mm. So this is what they given, and we have to find out the velocity of this ram. We have to find out the velocity of this ram. Okay. So first we have to draw this space diagram. Let us draw the space diagram. This is space diagram. For drawing space diagram, let us use a scale. Because here see, CD length is 300 mm. CD length is 300 mm. 300 mm means 30 centimeter. 300 mm means 30 centimeter. So you cannot fix this diagram inside the drawing sheet. Okay, that's why we have to scale it. So let us scale it. OA length is 60 mm and CD length is 300 mm, DR length is 400 mm. Let's scale like this. 1 centimeter equal to 50 units. Like this we will scale it, so that the diagram will fit inside the sheet. Okay. So first you have to draw OC. First you have to draw OC. What is the length of OC? Length of OC is 160 mm. 160 mm means here you have to draw 160. Every unit you just divide it by 50. Okay, wow. That is the scale we have taken. So 160 mm means 160 divided by 50. What is the answer? Answer is 3.2, I think so. Okay. So this OC length is 3.2. So draw OC first. Draw a vertical line. Okay. Draw a vertical line. Draw OC. Right. After drawing OC, take your uh, take your protector. Take your protector and keep your protector on OC. Keep your protector on OC and take 120 degree from here. This is 0. Okay. This is 0. So like this. Take 120 degree. Take 120 degree and mark it. So on this line, OA length is 60 mm. 60 mm means um, 1.2 centimeter, I think so. Okay. So on this line, take 1.2 centimeter. Take 1.2 centimeter. You get OA. Okay, and that is OA. Okay. Then what is the CD length? CD length is 300 mm. 300 mm means 300 divided by 50, I think 6 centimeter. Okay, 6 centimeter. So take your scale and keep one end of the scale here. Keep one end of the scale here and keep the scale like it crosses A. It crosses A and draw the 6 centimeter line. Okay. Draw the 6 centimeter line and that should cross point A. That should cross point A. So we got C. Okay. Already here 120 mm. 120 mm means it should be 120 divided by 50. It is 2.4, I think so. 2.4 centimeter. 2.4 centimeter. 120 mm means 2.4 centimeter. 120 divided by 50, 2.4 centimeter. So draw a line from O. Draw a horizontal line from O. That is the reference line, and above that reference line by 2.4 centimeter. 2.4 centimeter above this reference line, you have to draw one more reference line. Okay, va? Draw one more reference line like this by the height of 2.4 centimeter. By the height of 2.4 centimeter. Now, what is the length of RD? RD length is 400 mm. 400 mm means 400 divided by 50. I think it's 8 centimeter. 400 divided by 50, 8 centimeter. So take your compass. Keep one end on D and take 8 centimeter on the compass. Take 8 centimeter on the compass and cut the 8 centimeter line on the reference line. Cut the 8 centimeter arc. This 8 centimeter arc from D, 8 centimeter arc on the reference line. So that cutting point is R. Now we have completed the space diagram. Now space diagram is over. Okay, now space diagram is over. Now we have to move to velocity diagram. Mark all the points. Don't forget to mark all the points. This is O, this is C, and this point is A. Okay, this is slider. Slider name is B. So this slider is sliding on the slotted bar CD. See, before solving this problem, you should know the working principle of crank and slotted lever mechanism. Okay, if you don't know the working mechanism of crank and slotted lever mechanism, you cannot understand this problem. So if you don't know means, please go to first lesson and study the crank and slotted lever quick return mechanism and how it is working. And already I have shown some animation for that also. If you check my previous videos, There you can see, I think the video name is uh, inversion of Kranken lever mechanism. Okay, sorry, inversion of Kranken chain lever mechanism. In that video, go and check that video. And at that video, I have mentioned about this mechanism and how it is working. If possible, I will put the link for that mechanism in the first comment of the video. Okay, go there and see how it is working. Then only you can solve this problem. Okay, right. Now we have drawn the space diagram. Now we have drawn the space diagram. After drawing space diagram, what we have to do? After drawing space diagram, what we have to do? After drawing space diagram, you know the velocity of the crank OA. Velocity of the crank OA is 200 rpm. Okay, speed of the crank OA is 200 rpm. So based on that, you have to find out the angular velocity of the crank OA. Crank OA angular velocity 2 pi n by 60, and we got angular velocity of OA is 20.952 radian per second. 20.952 radian per second. 20.952 radian per second. So now this OB, velocity of OB will be angular velocity into link length. 20.952 into what is the link length? Link length is 60 mm. Go to the question. In the question it is given. Link length is 60 mm. 60 mm means 0.06 meter. You have to write it in meter. Okay, wow. Link length, OB length is 60 mm, but you have to write it in meter. Meter means convert it into meter, 0.06 meter. So 20 into 0.06, the answer is 1.257 meter per second. 1.257 meter per second. And we know in the question they are given, it is rotating in the clockwise direction. It is rotating in the clockwise direction. Now fix all the. Now we have to start velocity diagram. Okay, so put the title velocity diagram. This is space diagram. This is space diagram. This is space diagram, and now this is velocity diagram. So put the title velocity diagram. Velocity diagram, and you have to scale it first. First scale it. So what is the answer we got? We got only one answer, 1.25 meter per second. So 1 centimeter equal to, you can have as it is. You can have as it is. 1 centimeter equal to 1 meter per second. If you have as it is means you will get a small diagram. You will get a small velocity diagram. So what I am going to do is, one centimeter equal to 0.5 meter per second. I am going to keep like this. Okay, wow. You can have as it is. In this question, you can have as it is. You can have 1 centimeter equal to 1 meter per second. But 1 meter per second means this is 1.25 meter per second. So this line will be 1.25 centimeter line. That will be very small. Okay, wow. So what I am going to do is, I am going to enlarge the diagram by increasing the scale. 1 centimeter equal to 0.5 meter per second. So if it is 1.25 means how much length should be this one? 1.25 meter per second means you have to draw 2 point into 2, sorry, 2.5 centimeter line. Okay, 1.257 means here you have to draw 2.5 centimeter line. 1.25 into 2, 2.5, that's all, nothing else. Okay, so first you have to fix the point. Fix the fixed point. What are the fixed point? O is fixed point, C is fixed point, and this guide, they didn't name anything. Let us name this guide as Q. Okay, so Q is fixed point. So O comma Q comma C, O comma Q comma C, all are fixed points. So all the fixed point will lie in one place. Okay, one more thing, While drawing space diagram, you have to mention everything in capital letter. Okay, but in while drawing velocity diagram, you have to mention everything in small letter. Okay, so already I told all the fixed links will be at one point, and all the rotating links, crank and everything, will be acting in perpendicular direction. Suppose if you are going to draw the crank, means you have to draw perpendicular line, particularly in the downward direction, because it is in the clockwise direction. Okay, downward direction. How much length? 2.5 centimeter. So from this place, a perpendicular line, perpendicular to OA, perpendicular to OA, draw a line, perpendicular to OA, draw a line. Okay, and why they have mentioned B means this OA is connected on the slider B. OA is connected on the slider B. That's why they have mentioned B. Okay, this OA is connected on the slider B, so they have mentioned B. Okay, right. Next what is there? Next CD. Next CD. And this CD is starting from C. So draw a perpendicular line. See, draw a perpendicular line. Draw a perpendicular line to CD. From here, draw a perpendicular line. Just draw the perpendicular line. Okay. I don't know the dimension. Just draw perpendicular line. From C, just draw perpendicular line on both sides. On both sides, you just draw the perpendicular line. I don't know the dimension. You just draw it. You just draw it. Okay. You just draw it. Now, this slider, slider B is moving on CD. Okay, this is slider. Slider will move parallel direction only. For example, this R slider, this will move like this, but other links will move in the perpendicular direction. But slider will move in the parallel direction. So slider B, we have B point here, so we have to draw a line for slider. So slider will move in the parallel direction. Slider is moving on what? Slider is moving on the line CD. So draw a parallel line to CD. So it is meeting on line CD at point A, because slider is on point A. So it is meeting on point A. Okay. So already I have drawn line on both sides, but now I know this line will be on this side only, because point A is here. See here, CD link is there. A is somewhere between C and D. Similarly, here CD line, I don't know the length of CD, but I know where is A. I know where is A. Now I have to find out point D. Point D is on this line only, but I don't know where it is. Point is on this line only, but I don't know where it is. How I can find it? There is a simple method for that. Okay. Here I know CA length. Here I know CD length also. In this diagram I know CA length, but I don't know the length of CD. Now measure this length CA from your space diagram. From your space diagram, measure this length CA and write it here. Measure this distance CD from your space diagram, not from the question. Remember, from your space diagram. Measure this distance CD. Write it here. Measure this distance CA and write it here. And find the distance CD. After finding the distance CD, mark point D here and erase remaining lines. Okay. So we have drawn perpendicular line for OA. We have drawn parallel line for slider. We have drawn perpendicular line for CD. Still what is pending? Still RD is pending. Still RD is pending. Okay. So now we have to draw from D. From D you just draw a perpendicular line RD. Okay. I don't know the length. I don't know the length. I don't know the length. You just draw the perpendicular line. What is the final link? Final link is R. That is piston. Piston is sliding on the fixed line. I told you for piston you have to draw the parallel line. So from here you just draw the parallel line. And that is hitting RD line. So this is R. This is R. So we got all the points. We got all the points. That's all. That's all. We got all the points. Now what is the question? Question is we should find the velocity of the piston. So now measure the distance between O and R. Now measure the distance between O and R and multiply the value with the scale. What is the scale? I have used the scale as 0.5. Measure the distance of OR and multiply the distance with the scale. Scale value is 0.5. So you will get the velocity of the slider R. Okay. I hope you understand. If you didn't understand means please watch the video carefully, slowly. Okay. You will get the answer. You draw this space diagram and this velocity diagram in the drawing sheet. Okay. We will see in the next class with the next problem.